Welcome to another Deep Learning Nerds video. In this video, we want to take a look at recurrent neural networks, in short RNNs. We will explore how RNNs are designed and how they work. In contrast to classic feed-forward networks, RNNs allow backward connections to previous neurons. RNNs have a kind of short-term memory and can handle time series data very well. The core component of an RNN is the cell. An RNN cell represents a hidden layer in an RNN. The cell receives an input and generates an output. The special thing about the cell is that it has a feedback loop, which means that the output goes into the cell as another input. This is known as hidden state. Let's look at the cell at time t. The cell gets a normal input and generates an output. The output represents at the same time the hidden state. Due to the feedback loop, the hidden state is passed through time and is another input of the cell in the next time step. To understand the functionality of an RNN cell even better, we can unfold the RNN cell. The unfolded version visualizes the RNN cell as a graph over time that can be viewed at all points in time. This visualization clearly shows that the hidden state from the previous time step affects the hidden state of the next time step. By taking into account information from the previous time step, the system has a kind of short-term memory. This short-term memory is described in the form of the hidden state of the cell. This state is overwritten in every step, which means that the information is only stored for a short time. There are various options for the architecture of an RNN cell. Input and output are represented by sequences. There is an input sequence and an output sequence. This is known as sequence-to-sequence architecture. But input and output do not necessarily have to exist in every time step. This means the length of the input and output sequence do not have to be identical. Let's have a look at some sequence-to-sequence architectures. Here you can see a many-to-many architecture. In this example, there is an input and an output in every time step. Here you can see another many-to-many architecture. In contrast to the previous example, there is only an input and output in certain time steps. In the first time step there is no output and in the third time step there is no input. Here you can see a one-to-many architecture. In this example, there is only an input in the first time step but an output occurs in each time step. Here you can see a many-to-one architecture. In this example, there is an input in each time step but an output only occurs in the third time step. Congratulations! Now you are one step closer to become an AI expert. You have seen how an RNN is designed and how it works. The most important component is the hidden state, which acts like a short-term memory. There are numerous models that are based on the concept of RNNs, such as the LSTM networks. Have you ever used an RNN? What are your experiences? If you enjoyed this video, make sure to like and subscribe below. Thanks for watching. See you in the next one.